Welcome, guys. In our previous lessons on AC circuits, we learned about alternating current and voltage and how they are influenced by the presence of resistors, capacitors, or inductors. To further understand the effects of these circuit elements on alternating current and how these elements interact with each other in the presence of alternating current, we will introduce the concept of phasor diagrams. Phasor diagrams are graphical representations of the magnitude and direction of two or more alternating quantities. They are usually represented by a vector rotating in the anticlockwise direction with an angular speed omega. The length of the vector is directly proportional to the magnitude of the current or voltage that it represents. You may have seen waveforms like these and heard terms like current leads voltage or current lags voltage. And perhaps you didn't really get it. Phasor diagrams will help you see whether voltage or current in a circuit are in phase or out of phase very easily. So let's take a look at a simple phasor diagram. Given the waveform of an alternating current just like the one on your screen, with the equation I equals to I naught sine omega t, the maximum current is I naught, and we can draw its phasor diagram as follows. Draw the vector I naught, which is equal in length to the amplitude of the waveform, at an angle to the x-axis. The angle between the vector and the positive x-axis is the angle through which it has rotated thus far, which is equal to omega t. Note that the phasor rotates in an anticlockwise direction. The projection of the vector on the y-axis, which is the y component of the vector, is the magnitude of the current at any time t. We can visualize this using the illustration on your screen. As the current starts flowing, it flows from 0 until it reaches the maximum value, then goes to 0, then goes to the minimum value, and from there goes back to 0. As you can see on the screen, the phasor diagram is back to where it started. Now let's use this knowledge to draw the phasor diagram for circuits containing a resistor. We know that current and voltage are in phase in a resistor. So we start by drawing current as a vector whose length is equal to I naught and an angle of omega t. The angle is omega t because the phasor rotates with an angular speed omega, and after t seconds it would have covered an angle of omega t. Now taking the y component of the vector, we get I naught, which is the length of the vector sine omega t. Now let's draw the phasor diagram for the voltage. We know that the voltage is in phase with the current. So we're going to have a phasor diagram that looks like this for the voltage. The phasor has a length v naught at the same angle omega t. The y component of this vector will be equal to v naught sine omega t. And since they lie on a single line, we know that I of t and v of t are in phase. So as the current with respect to time, I of t, and the voltage with respect to time, v of t, rotate, the two vectors will lie on the same line. And this is a nice visual representation that will come in handy when we start analyzing circuits that have resistors and other components. So join me in the next phasor lesson as we learn how to draw the phasor diagram for an AC circuit that has a capacitor or an inductor. Keep learning.